Oh, okay. Uh, my PowerPoint presentation is visible from your side.
Yes, sir.
Sure.
Okay. Uh, now, the binary relationship and non-binary. The non-binary uh, means more than relationships associate with more than two entity sets. Say ternary relationship sets, which can associate three entity set. For example, in our previous class, I have discussed uh, the work on relationship associate the uh, customer, branch, and job. Okay, or maybe there is a relationships belongs which can relate the three entity sets, say customer entity sets, branch entity set, and account entity set in the banking database systems. So, but some of the that means some of the relationships there exist that may appear as a non-binary, but it can be sometimes better represented by a binary relationships, or maybe sometimes some of the relationships can be represented more meaningfully as a ternary or non-binary relationship set. Okay, just 1 minute. For example, uh, the ternary relationship, say parent, that can relate. This is the relationship set which can relate the child entity set, father entity set, and say mother entity set, and this can be represented by a uh, more meaningfully, or that can contain the more uh, clear information that if we represent by a two binary relationship set, that is, if it is a ternary relationship set, that is parent is relate the child entity set, father entity set, and as well as the mother entity set, then it can include all the informations if the information about uh, his both the parents, that is the father and mother's, known, but it cannot store the information if one is known. Okay, and but there are some of the relationships that are naturally non-binary, whatever actually I told just beginning of this class. For example, the work on relationship which associate the entity set, employee, branch, and job. This one, this work on relationship set, this relate the employee entity set, branch entity set, and job entity set. Okay, now I am in the slide number 29. 29. Is it visible from your side?
Yes, sir.
Okay. So this is the work on relationship. This is a ternary relationships, and this ternary relationships is a
No, sir, sorry. Which slide did you say? 29, sir.
29.
Sir, no, sir. It's not visible, sir. We are still at 31.
I think some other students seen. That means the problem in
So,
your network.
sir, on slide
And
30.
last day maybe my
No, sir.
network problem.
Everyone is saying the same, sir.
What?
So even the rest can't see, sir. It's still at 31 only, sir.
Yesterday?
Sir, it was not only on my computers. It was on everyone's computer, sir. Even right now, sir.
Someone actually told me it is seen in 29.
No, sir.
Sir, it is
Sir,
on 31.
Sir,
sir,
I only
31 is
said
visible.
the 31 is visible, sir. I only said, sir. By mistake, I thought that was 29, sir.
Okay. Okay, just 1 minute.
It is showing 31.
Which slides actually you've seen from your uh,
Sir,
from your
yeah,
side?
external relationships, sir.
ER diagram.
Slide number 29. Okay. Okay, just you can see in here the slide number 29. This one actually I already discussed in last class, but this work on relationships is a ternary relationship set. Okay, this relationship relate or associate the employee entity set, branch entities. Oh, sorry, branch entity set and as well as the job entity set. Okay, now which slide actually you've seen?
Sir,
Sir,
binary versus
non-binary,
non-binary.
sir.
That means 31 slide number. So here actually, whatever actually I want to talk today, there are some of the relationships that are naturally non-binary. That is, for example, work on just that relationships how actually associate with the employee, branch, and as well as the job. These three entity sets I shown uh, just before that slide. And there is a another example, say the relationship says CAB, which associate the entity set customer, account, and branch. In the banking system, the customer, what is attribute? Customer name, customer ID, say customer address, customer city, so on. Account is the attributes are account number and balance. Similarly, branch is the branch name, branch asset, so on. So these are actually this CAB that associate the customer, account, and branch. These are actually naturally these are the ternary relationships. So is it possible to convert this one in a binary or not? Means we can see uh, that can uh, uh, I mean that can preserve the all the information reflected or all the information reflected by the ternary relationships if we consider, or if we consider the binary after conversion, then it also conserve the or preserve the all the information or fact or not. So it's better actually we can consider with the example. uh, suppose suppose the example we can consider the example is the relationship in between the customer entity set, account entity set, and branch entity set. Okay, so suppose the relationship is the CAB and it can relate branch entity set. For the simplicity purpose, I have not written to name. Account and customer entity set. Okay, that is that means CAB relationship is a ternary relationship which associate the customer entity set, account entity set, and branch entity set. And what is the mapping cardinality here? The customer side is the many, account side is the many. That means multiple account is possible. Uh, the particular customer can open a more than one account is possible. And this side is the branch side is the one. Why? Because when the customer open an account, that account belongs to a particular branch. Is it no? The particular account does not belongs to a more than one branch. Any account belongs to a particular branch. For that, this branch side is a one. The mapping cardinality is the here. Customer to branch side is many to one, and as well as the account to branch side is many to one. Is it clear? Is there any question? Is there any question?
Sir, is the branch side 1-to-1, sir?
1-to-1. Why 1-to-1? Which one 1-to-1?
Sir, branch to CAB.
branch to CAB, CAB with the branch is one. That side, that is the particular branch only, not more than one
Yeah.
branch.
Okay, sir. Okay, sir.
Okay, it reflect the real fact, because what is the reason behind that? That side is one. What is the reason behind that? The customer have any number of account. It's possible. For that account side is the many, but particular account for a particular customer, of course, or maybe the joint customer, that account belongs to a particular branch. The account does not belongs more than one branch. So for that, the branch side is the one. Cardinality is one. Okay. So this CAB relationship, CAB specify that a customer may have several accounts, each located in a specific bank branch, and that an account may belongs to several different customers. That is, the joint customer is possible. The account, that means account can hold a more than one customer, joint holder, account holder. And similarly, the one customer can have more, any number of account in the bank, but account, of course, associated with a single branch. Okay. So if we replace, the meaning is clear, na? If we replace this one as a pair of binary relationship set, suppose we want to replace it by a pair of binary relationship. Set. Okay. So here, just a minute. Here customer entity
Your
set.
voice is not clear.
Now I want to convert this or replace this ternary relationship CAB into a pair of binary relationship set. Okay. And we want to check
Your voice.
the what. Please pardon me. Pardon me. And I want to check the whatever the fact actually I told, which actually represented by the ternary relationship CAB. What is the fact actually reflected by the CAB? I already told. This, it specifies that a customer may have several accounts, each located in a specific branch. Specific branch. That is, account is associated with a only one branch, and that an account may belongs to several customers. That is, joint account holder is possible. Now we want to check if we convert this one in a binary relationship set, pair of binary relationship set, to reflect this here diagram, or to replace this fact, it can reflect the all the things or not. Now customer and account, this two entity set is related, say cast account, or say for simplicity we can write the CA. Okay, CA is the cast account, customer and account, and account is related with the branch by another relationship, say account branch. Okay, that is, we convert this. Says this is a figure. Say this is figure 1. Say this is figure 2. Okay. AB means actually account branch. Okay, and CA means customer account or cost account relationship. So CA and AB, both the relationships are here binary, is it not? Because CA relationship is associated with the customer and account entity set, whereas AB relationship is also binary. It can relate the two entity sets, account and what? Branch. Is it not? It can relate, this one actually relate account and branch. Okay. Now you see here each account, if we consider this relationship AB, by the AB relationships we get the fact the account is located in a particular branch or account is associated with a particular branch. Okay, is it clear now? Because this side is the many, this side is one. Here this is a many to many. Okay, the account is associated with a single branch, and this cost CA, this one, the CA relationship is associated with the customer and account. Customer and account, these are many to many, which means a customer may have, what is the meaning of that? That is, this relationship is associated with the customer and account. What is the meaning of that? Customer have any number of account, and because many to many, from customer account to customer also, for that any account can hold by jointly by several customers. Okay, so both are same or not? Am I audible?
Yes, sir.
So now question is actually both are same or not? Means in the first, actually the figure 1, the ternary relationships, here customer have any account, any number of account in a particular branch. Account can associate with a single branch, and similarly here account can hold jointly by any number of customers. Okay, that fact also reflected here. The account is associated here, account is associated with at most one branch. That is, account is associated with a single branch. And if we consider this side and this side, that is the customer and account, the customer have any number of account, and account can hold by any number of customer. That is, the joint account is possible. Is there any other difference? So we can say that both the figure 1 and figure 2 are same, or there is any distinction is there? Can you tell me? Whatever up to that, whatever I told, is it clear?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
Okay, so now though we can see the figure 1 and figure 2 both reflect the more or less same fact, but there is a little or suitable distinction is there, or difference is there. What is this? The former, that is the figure 1 CAB relationship, this CAB relationship between customer and account can be represented only if there is a corresponding branch. That is, this is a ternary relationship, CAB. You can see the figure 1. Okay, customer and account can be represented only if there is associated with a corresponding branch. Okay, but later in this figure 2, where the it is converted in a binary relationship CA and AB. In this case, account can be either related with the branch account. This account, so okay, we can just change the color. Account can related with a branch with no corresponding customer. It is possible by figure 2, because this is the relationship AB is a binary. So there may be possible the account number is there and that belongs to a particular branch, but that for that account there is no specific customer is there. And similarly, it is also possible here the customer have account without connecting or without associating with any branch. You try to understand the distinction of the figure 1 and figure 2. Ternary relationship CAB and two binary relationship, equivalent to binary relationships CA and AB. In case of figure 1, here customer have account. It's possible if this account is associated with one of the branch. But in figure 2, it is not necessary. There may be some account is there, that account in a particular branch, but that account is not associated with any customer. Similarly, the customer have account by the relationship CA, any number of account or single account or any number of account by this relationship CA, but there may be possible that account is or customer is not connected with any branch. So what is the meaning of that? In the banking enterprise system, if we consider, the ER diagram in figure 1 is more appropriate. So what is the important things? So for the banking system, the ER diagram of figure 1 is more appropriate than figure 2. Why? Since an account is always expected to relate or to associate both, and right here, to relate both a customer and a branch. Is it now? So figure 1 actually more clearly reflected all the facts, because figure 1 can reflect any account is associated with a customer and as well as the branch. But in figure 2, that may not be for all cases. Is there any question? Do you have any question? Yes or no?
No, sir.
No, sir.
Now, use of entity set or relationship set. The question is the particular object. Uh, Suppose the in previous example, the account. We can consider the account is the this account object is the entity set. Customer object is the entity set. Branch is the entity set. Why branch is not a relationship set? So question is actually the sometimes it is not clear whether the object is best suited or best we can express by an entity set or relationship set. In the previous whatever I here discussed in both the figure 1 and figure 2, the bank account is modeled as a entity set in both the figure. In case of binary relationship in figure 2 and as well as the ternary relationship set CAB in figure 1. Now I want to model the account entity set as a relationship set. So what is the ER diagram right now? If we consider the account object is reflected by a relationship set instead of entity sets. Okay, earlier actually we consider the account is the entity set. Now we consider the account so one thing I already told the attribute I have not right, that is the every entity set there is a desired appropriate attributes are there. Okay, for simplicity we have not drawn the attribute. Now this account is related. Okay, just a minute. Right now you've seen the slide number 33. Is it okay? Slide number 33 at present. Please confirm anyone of you.
Yes, sir. Slide 30.
Because the last day we faced the problem and today also beginning. Now we can see here the account, we can consider the account object as a relationship set, binary relationship set. The account relationship set is associated with the two entity set, customer and branch. And account entity set, we consider the two descriptive descriptive attributes, say account number, and another one is the balance. Okay, so account relationship associate the two entity set, customer and branch, and account and relationship set have two descriptive attributes, account number and balance. Okay, so say this is the figure 3. Now I want to see, or we want to see the whatever the information reflected by figure 1 and figure 2 is reflected here or not, or that means this figure 3 is good approach or not. Can you tell me, anyone from you? Please observe the figure 3 and compare with the figure 1 and figure 2. Please tell me, anyone from you? Yes or no? The figure 3 is equivalent figure 1 and figure 2. Am I audible?
Yes, sir.
The figure 3, this figure 3, the customer may have an account at many branches. So this side is many and this side is many. Customer may have account in many branches, and a branch may have many customer or any number of customers. Okay, and each account, that is the account number and balance, by that represented by a relationship between a customer and a branch. Okay, so this one, this reflect a customer may have an account at many branches, and similarly a branch may have any number of customers. Is it? And each account is represented by a, by a relationship between a customer and a particular branch. Okay, so everything is correct here or something missing? You can see the earlier figure. You can see in figure 1, suppose the figure 1 ternary relationship, here customer have or account can hold by multiple or joint customer, and of course that account belongs to a particular branch. And figure 2, figure 2 may reflect the joint account, but problem is actually there sometimes the account is not associated with suppose branch but associated with a customer, or maybe the customer having an account, maybe the account hold a joint customer but that does not associate with any branch. That is the problem in figure 2. Now you can see the figure 3 here. This one actually support the joint account. This figure 3 cannot conveniently represent the situation of joint account. That is, the account belongs to several customers. Okay, which means, you understand or not? Please Please either tell me yes or no.
Yes, sir.
It is here figure 3 cannot represent conveniently a situation like in which sorry in which several customers hold an account jointly. Okay. So if we assume there is a no joint account is there, then figure 3 is okay. If the banking system consider or allow a particular account can hold by a multiple customer, then figure 3 does not reflect correctly. Okay, does not reflect correctly. Okay, that is if there is not a joint account, then sorry, then the design of this figure 3 is satisfactory. Okay.
So why is a joint account? So because customer is many, sir. So multiple customers can hold one account in one branch.
And just a minute. Just 1 minute. Now, please tell me.
Sir, why can't a customer hold a joint account in this ER diagram, sir? Because many customers are holding one account in one branch.
Now,
Many to
account
many
is
also
the
accommodates
account.
many to one, right?
Many to no, please see here carefully. How we can say that this account actually hold by many customer. Account is the relationship set. Each of the entity of the account is the one of the account number and balance. You try to understand. Each of the account number is the, that means in the account entity set need to be placed the same entity multiple times. Account is the entity set. That means there are account type of entities are there. Account number balance, account number balance, account number balance. So if the particular account, say 123 is the account number, if that account hold by two customer, say Ajit and Sumit, so what happens in the account entity set, same account number 123 need to be placed twice, two entities in the same entity, na, for the customer Ajit and for the customer Sumit. You understand my point?
Okay, so
The account is
basically in the
the
relationship set, sir, two customers cannot access the same account, numbers and balance.
uh, this customer side is many and branch side is many means account relationships associate the two entity sets in many to many relationship or cardinality, which means the any number of customer, that is any number of customer is associated with any branch via the account relationship set. And in a particular branch, any number of customer is there via relationship account. That means customer and branch is associated with account. Without account, the figure 2, the problem in figure 2, what is the problem? There may be customer and account is associated, but account is not associated with the branch. But here, no such problem is there. Customer is associated with branch with a account number. Without account number is not possible. That means if customer is associated with particular branch, of course the customer have some account. Okay, but a particular account or particular entity of the account entity set, that means particular account, we cannot say that can hold by any number of customer or that can associate with any number of branch. You understand my point? Not this account, just a minute. This account is the relationship set. Now, this relationship set, there are several accounts of relationships are there. This is the one account number and balance. This is another account number and balance. That is account number and balance, account number, balance, account number, balance. All the entities, these are the account entity. This is the set, account entity set. This is the each of the account. This is another account entity. This is another account entity, and these all are actually distinct. All are distinct. So how we can say this particular account with balance say 5000 hold by any number of customer? If it is hold by any number of customer, then same thing need to be repeat here. Is it done? So at that time we can say because this account number and this account number is the same. So Ajit hold this account number and Sumit hold this account number. That means these are actually joint account because the account number is same. But it is not the fact here, because account entity set contain a distinct account entities. Is it done? Account relationship set, this does not contain a duplicate relationship set. This is sorry, here I am write the entity. It is not the entity, it is a relationship in this case. You got my point or not? That is, by this figure, it is not possible to say the particular account hold by any number of customer and as well as it can associate with any number of branch. If your point is correct, suppose if we consider the account hold any number of customer, then account also hold by or associated with any number of branch, because this side is many. But that is not the case, because in each entity set customer or branch and as well as the relationship set account, they are actually distinct. The number of relationships inside the relationship sets are distinct. Similarly, the number of entities in the customer entity sets are distinct. The customer entity sets does not contain the same customer more than once. You got my point? Yes or no?
Yes, sir.
Okay. So the solution, how we can tackle this? How we can tackle this problem? We can tackle this by by introducing. I mean, by introducing another relationship, joint account. So we can draw the figure. Just a minute. I change the color. Say, say customer entity set account. This is the branch. Okay, this side is many, this side is many. Okay, and here account number, and another descriptive attribute is the balance. Okay, in the previous slide, but here problem is there. This ER diagram does not tackle the joint account holder, the case of joint account holder, that is the account held by a multiple customer. So for that we can create another another relationship, say joint account. Okay, now you can see this figure 4 can reflect the all the things. Okay, but overall figure 1 is the best one, or figure 1 is the more appropriate with respect to figure 2, 3 and 4 also. That is, we can introduce a separate relationship set that can reflect the joint holder of the joint account. That is, the multiple customer have the joint account. Okay. Now, in general, if we want to convert the non-binary relationship to binary relationships, there is certain rules are there. The relationship, ternary relationship or non-binary relationship set, say R is the relationship. This relationship set is associated with the 3 entity set A, B and C. Okay, that is R is what? Ternary relationship set, which is associated with A, B, C. Now the appropriate slide is visible from your side, na? 35 slide number. Slide number 35 is visible from your side.
Sir, we can't see the slide number, sir, because we are on slideshow mode, sir.
Okay, whatever actually you can see, the converting non-binary to binary relationship, is it that?
Yes, sir. Yes, sir.
Whatever actually I told, that is reflected by the slide, is it or not? The R is the relationship in the figure, which is associated with the entity set A, entity set B and entity set C. Okay, now if we want to convert this in a binary, equivalent binary relationship set, that is the R is the ternary relationship set, we want to convert this a binary relationship set, then R is replaced by one of the entity set. We can create one of the dummy entity set E and 3 more relationship. These 3 relationship sets are binary. These 3 relationships are binary. That is, RA is the relationship set associated with the E, and it's better if we show the figure. You can see here the relationship set R is replaced by the another dummy or created entity set E. We also use the three relationship set RA, RB, RC. What RA? RA is associated with the entity set A and dummy entity set E. RB is relationship. It is a binary relationship because it associates with the two entity set. What are these? Entity set B and entity set E. Similarly, RC. Okay. Up to that is clear. That is, this is the general rule. If we want to convert this one in a binary relationship set without violating whatever reflected by the ternary relationship set. Okay. So and for that actually need create a special identifying attribute for E. Add any attribute of R if this relationship, ternary relationship R contain any descriptive attribute, then that can also add with the E, entity set E, because the R is replaced by another entity set E. Okay. And for each relationship, that is, this relationship R is associated with what? Entity set A, B, and C. That means entity set A is AI, entity set from B is BI, and from C is CI. That is, this is the one of the relationship. This relationship associate what? Entity set A, B, and C. So this relationship AI, BI, CI, which is created here, for that create a new entity EI in the entity set E and add EI AI to RA. Is it clear or not?
Yes, sir.
That is, for E, there is a entity set is the EI. So now question is, what is the entity, what are the relationship of this relationship set? RA is the relationship which can relate the two entity set A and E. So what is the relationship here? The relationship is EI, the entity from the entity set E, and AI. Okay, this AI. Similarly, add here EI and BI, and here EI and CI. Okay. So this is the general rule. If you follow this, then the whatever actually information reflected by the ternary relationship set can also reflected by the this binary relationship set. So you can check the previous example, whatever I have discussed just before this slide. I can continue another 15-20 minutes. For that, actually, I can consider this class as a 2 class. Okay. Now, next one is the weak entity set. Up to that, any question? Yes or no? Either yes or no. Anyone from you?
No, no, sir.
No. Okay. So next one is the weak entity set. The entity set that does not have the primary key is called the weak entity set. That is, if any entity set there is not a sufficient attribute which can uniquely identify the entity from the entity set is called a weak entity set. Okay. And when we say the entity set is a strong entity set, if in that entity set have a sufficient number of attributes is present or available to uniquely determine each of the entity from the entity set. That is, strong entity set means their primary key is there or attributes are sufficient to act as a primary key, and weak entity set means there is not a sufficient attribute is there to form the primary key for that entity set. At that time we call it weak entity set. Is it clear which one is the weak entity and which one is the strong entity? And weak entity set is represented by a double triangle, and the existence of this weak entity set, which one weak entity set? The entity set does not have primary key. That is, there is a no sufficient attribute which can form the primary key. Why primary key is required? To uniquely identify each of the entity from the entity set, or in case of relationship set, each of the relationship in the relationship set. Okay, so in weak entity set there is a no primary key is there. So for that, the existence of the weak entity set depends on the another strong entity set. That is, the existence of the weak entity set is depends on the existence of the strong identifying other identifying entity set, which is a strong entity set, and it must relate to identify the entity set via the total participation. This is a total participation. This is total participation. Okay, that is total participation one to many relationship set from the identifying entity set. That is, the identifying entity set means strong entity set to the weak entity set. This identifying entity set means this is a strong entity set. Okay, and it's better actually if we show the picture or show the ER diagram. You can see here the loan is the strong entity set. This loan is the strong entity set, whereas the payment, this is a weak entity set. For that, it is represented by a double line rectangle. Is it clear? Double line rectangle means this is a weak entity set, and this is a strong entity set. Okay, you can see here this payment weak entity set, it existence of the payment entity set is depends on the strong entity set loan via a relationship loan payment, and when the relationship is associated with the strong entity set and as well as the weak entity set, at that time it is reflected by a double line diamond. Okay, it is reflected by a double line diamond. Is it clear? What is weak entity set, what is strong entity set is clear. How it is represented in the ER diagram is clear. Or any question? So weak entity set is represented by a double line rectangle, and relationship set which associate the strong entity set and as well as the weak entity set is represented by a double line diamond shape symbol. Okay, now here you can see this solid line loan number. Loan is the strong entity set. The loan number is the what? Loan number is the, please tell me. Loan number is the primary key. But in case of payment, there is not a sufficient attribute to form the primary key. But the payment entity set, there is each of the entity in the payment entity set are also distinct. How distinguish that? For that, discriminator is there. This is the discriminator or partial key. This is the partial key. It is not a primary key by the dash underline. Solid underline is the primary key here, loan number, and this is the dash underline is the payment number is the called a partial key or discriminator. Partial key or discriminator. Okay, that means discriminator of a weak entity set. Discriminator of a weak entity set is the set of attributes that distinguish all the entities in the entity set. So here you can try to understand the payment entity set. All the entities are distinct. How we identify? By the payment number. But still it is not a primary key. Why? The primary key here in case of loan number also uniquely determine the each of the loan entity. Why it is not a primary key? Because the existence of the payment depends on the loan. If there is a no loan is there, then there is a no corresponding payment of that loan. Okay, so in that case, the primary key of this weak entity set, the primary key is actually formed by the primary key of the strong entity set on which its existence dependent, and discriminator, that is the payment number. That is combination of loan number and payment number form the primary key of the payment weak entity set. Okay. That is primary key of the strong entity set on which the weak entity set depends, and as well as the its discriminator. So is it clear? Is there any confusion in this example? Yes or no?
No, sir.
There is another example, say flight and departure. The flight and departure, here departure is the weak entity set. Okay, one thing, there is a mistake is there. That is by our convention, this is a double line rectangle. Okay, this is a double line rectangle. Okay, this is a double line rectangle. That is the departure here as a weak entity set. Its existence depends on the another entity set or strong entity set flight. That is this is a weak entity set, and this is a strong entity set. The flight entity set, which one is the primary key? Flight number. And departure have the descriptive attribute date, and this is the discriminator also. That is the partial key is there. The each of the entity of the departure is distinct. That means in this entity set, weak entity set departure, each of the date are actually distinct, but single date can share by a multiple flight. This is because the fact that each departure entity is distinct, but different flight may have departure on the same day. That is same date, say today 25th August, can fly more than one flights. So that more than one flights, all of them can share the today date in the departure entity. Okay, for that the date is not the primary key of the departure entity. So what is the date? Primary key of the departure entity. What is the primary key?
Sir, date and flight number.
Flight number. Okay, good. That is the primary key of the departure. That is primary key of the weak entity set is flight number, comma, date. Okay, flight number, comma, date. So this is the case of weak entity set. So I hope the concept of weak entity set and strong entity set and how we can form the primary key of the weak entity set, what is the discriminator or partial key of the weak entity set, the idea is clear. Or
Sir,
is,
one question, sir.
sure.
So in the previous slide, sir, it was written that the relationship, the identity relationship is a one-to-many relationship from identifying two weak sets, sir. So, but in the diagram, sir, the arrow is pointing towards the identifying set. So, what?
Here is pardon me, one
So,
second.
the second point. So, the second point, sir.
Okay.
Sorry, sir. Wait 1 second. So, probably the previous slide. The previous slide, sir. Yes, sir. It must relate to identifying set by
Actually, this
total
one.
one. Yes, sir. From identifying
one to many relationship between
identifying to the weak set, sir. But why the arrow is towards the
this is a one, this is a many side.
yes, sir.
And also that the payment is the total participation. That means there is all the entities of the payment, weak entity sets are participated in the relationship set loan and payment to associate the loan. Okay, for
Sir,
the total. Okay.
So my question is that, sir, it said that it's only identifying to the weak entity set, sir. But the arrow is from the weak entity set to the identifying set. So is that a printing mistake?
Arrow is from towards the payment. What you want to tell? Please pardon me again.
Sir, the arrow is towards the loan side, sir, which is the identifying side, sir.
Okay.
But in the statement it's given, it's from the identifying to the weak side, sir. So should the arrow be towards the payment side?
One to many relationship set from the identifying to the weak entity set. There is some mistake is there. Maybe this side it may be one to many or one to one is also possible. Okay, but the main fact that is the arrow key is reflected here opposite side, that is this side. Okay, just I can think about that. The particular loan have a payment. Yes. Now there is a mistake is that is actually many to one, or maybe the this side is one is okay. Okay, here mistake is there, many to one. If we say the identifying to the weak entity set here, because the loan is associated with any number of payment, that is for a particular loan can be disbursed or payment number of times, but a particular payment is associated with one loan. Okay, the particular payment means is a combination of loan number and its discriminator payment number. Okay, this one is, I can correct it later. This one is actually just opposite. You can think like a many to one. Oh, no, this one is identifying to the whatever actually written, it is okay. No? What is the problem? Just a minute. Whatever actually written, this is a one to many is fine, na? What is the problem?
The problem is the arrow, sir. It has been said that it's the relation is from the identifying set to the weak set, sir. But
Just
the
a
arrow over here is showing from the weak set to the identifying set, sir. That is my
no,
question.
no, one to many relationship set from I sorry. One to many relationship set from identifying set to the weak entity set. So one to many. That this side is a one now. Is it okay?
Yes, sir.
Identifying which one identifying entity set? Loan. So it's okay. One to many. Not
Sir, in the diagram, so my question is not about the one-to-many part. So my question is about the arrow, sir. Why is the arrow
arrow is
going
the
towards
diagram.
the
Arrow is the in the correct position. That is the this side is the one. That is one
okay,
to
sir.
many. Identifying side is the one, and many is the which side? Many is the weak entity side. So say here actually many side. One to many. It's okay. That is not.
Yes, sir.
It is a one to many relationship. It's correct. Whatever actually written earlier, it is correct. Okay. So now the next one is the generalization and specialization. Though the both are actually just inverse of that, the similar concept, but there is a little differences there. The generalization is means these are the two important relationships that exist between the higher level entity set with the lower level entity set. That is, generalization and specialization are used to relate with the higher level entity set with the lower level entity set, and which one actually represented by a triangular complement, and right inside them is a okay. That is generalization and specialization both actually represented by the this symbol and by this keyword is a. The generalization is the bottom up approach. That is bottom up design process combine a number of entity sets, that is the lower level entity sets, that share the same features into a higher level entity set. That is combine the number of lower level entity sets to get the higher level entity set. That is it is a lower, that is bottom up approach. For example, suppose the entity set account with the attribute, you know, the account number and balance. Now we classify this one as a saving accounts and checking accounts. Those saving accounts and checking accounts have the same property. That is, the saving accounts also contain the account number and balance. Checking accounts also contain the account number and balance. Except this common attribute, account number and balance, they have their other attributes are there, distinct, that are actually distinct from the saving accounts attribute and checking account attributes. That is, saving accounts and checking accounts, these two entity sets are some commonality is there. What are the commonality? Commonality is the both of them share the account number and balance. That is, both of them share the features of the account. So each of these we can discuss with example, it's better. And whatever this commonality, that is that this commonality can be expressed by a generalization and as well as the specialization, which is a constant relationship that exists between a higher level entity set and one or more lower level entity set. And generalization is a result of taking the union of two or more lower level entity sets to to produce the or to get the higher level entity set. So now I want to show with
Sir,
example. Please tell me.
sir, sir,
Uh,
sir, we have a open lecture class, sir, in 10 minutes, sir.
your class is from 2 o'clock, na? My class also in 2 o'clock. Another class is there, but the lunch break from 1
No,
o'clock.
sir. Sir, actually, in what do we say? Sir, in fluid mechanics, sir, we have a class from 12:45, sir.
Okay, just 5 minutes only.
Okay, thank you, sir.
Just a minute. Say I can show only the one example at least for this discussion. That is whatever the I told you the account. Account is the one of the entity, and they have two descriptive attribute: account number, and which is the primary key, and balance. Okay, another attribute. And we want to say the another savings account have the savings account and checking, or maybe the current account and something checking account. Okay, the saving accounts have descriptive attribute interest rate, and checking accounts have the other attribute, not the interest rate, overdraft amount. Overdraft amount. Okay, you can see the saving accounts also have the account number and balance, and as well as the checking accounts also have the account number and balance. So we can say reflected by is a that is this is the lower level, that is a this is a bottom up approach. This is the generalization. The lower level entity set saving accounts and checking accounts contain the higher level attribute of the higher level entity set account number and balance. Account number and balance is there, but it is not right here. It is right in the upper level entity set account with that. That is the saving accounts and checking accounts have some commonalities there. What is the commonality? Both are actually account. That is, both are the some common features. What are the common features? Account number and balance is there, though they are distinct. Why? Because saving accounts have another descriptive attribute interest rate, and whereas checking accounts have the another descriptive attribute overdraft amount. Okay, so this commonality is expressed by a I mean the generalization. Or if we think the specialization, that is the specialization is the top down approach, just opposite of generalization. That is subgrouping with the entity set that are distinct from other entity set. So if you think this example from bottom up approach, that is a generalization. This is just a minute. This is generalization. If we think top down approach, then it is a specialization. Okay, that is specialization is the result of taking a subset of the higher level entity set to form the lower level entity set. Okay, just like attribute inheritance, the lower level entity set inherit the attribute, all the attributes of the higher level entity set. That is, saving accounts and checking accounts inherit all the attributes, account number and balance of the higher level entity set account. Okay, so So the term, whatever actually I told, generalization and specialization are used interchangeably. Okay, we can another example. Just it is already written. That is, suppose the faculty. Faculty is the one of the entity set in the university system. Faculty consists of property, employee name, employee address, and so on. Faculty may be a professor, associate professor, and assistant professor. So, as professor, associate professor, and assistant professor, all of these three entity sets, lower level entity sets, inherit the features of the higher level entity set faculty. What are the features? Employee code, employee name, address, and maybe the some other things. And here the professor may contain some other attribute, maybe the administrative responsibility. This is the administrative responsibility. Administrative responsibility. Okay. Whereas the assistant professor, they have no administrative responsibilities there, and associate professor, maybe some other things are there. Okay. So professor, associate professor, and assistant professor, these are the lower level entity set. This inherits the features of the higher level entity set faculty. That is, professor, associate professor, and assistant professor have the some commonality. What is the commonality? All the three entity sets, professor, associate professor, and assistant professor, have the commonality is the employee code, employee name, and address. These features are there. But other than these common features, they may have some other features also. Maybe. Okay, do you have any question, please? Do you have any question or any clarification?
No, sir.
No, sir.
Okay, so you have some other classes. Please leave from the class. I can consider the attendance as a equivalent to 2 classes.